Hi, everybody. Today we'll go into part four and go into the sample size of validation batches. So, in this um, section, we'll determine batch size of validation runs following regulatory expectations. So, as far as sample size, the European Agency for the Evaluation of Medicinal Products, Committee for Propriety Medicinal Products 2001 says pilot batch size should correspond to at least 10% of the production scale batch. The European Medicines Agency guideline on process validation for finished products, information and data to be provided in regulatory submissions in 2016 says some process validation studies may be conducted on pilot scale batches. Pilot batch size should correspond to at least 10% of the production scale batch. So if you're doing a pilot batch or doing a sample batch size and you want to validate it, at least try to do something on a smaller scale, you should do at least 10% of your production batch scale in order to test, validate, and do validation studies. So that's the general consensus as far as sample size with batches and validation. So the validated range, this is an example. Say your batch size is 8,000 liters. So that with that range, your validated range, so if you're doing a test, your minimum batch size should be 7,200 liters, and then the maximum batch size should be 8,800. So that's your validated range. So if you're targeting 8,000 within that threshold, 7,200 is the minimum batch size, or you can go up to 8,800. So this corresponds with that 10% scale. Now we'll go into autoclave examples. So in this section, we'll describe how an autoclave works. I guess if you've taken my BioWorks class, you have seen how the autoclave works, but we'll go into more of how to validate it and going through the steps of IQ, OQ, PQ. If you remember, those are the validation steps from the previous lectures. So we'll list the three phases of a sterilization cycle and provide the requirements for the successful installation and operational qualifications of an autoclave. So in this picture, we have examples of an autoclave. Here you'll see a tabletop autoclave, and then that's on your left, but on the right is more of a production scale autoclave. So definitely much larger, be able to fit larger pieces of equipment. So the right side is more of a production scale, left side is more of what you see in the lab. In the lecture or in the section for this course or this module, I do have a video of an autoclave example, so please watch that. And it'll go into details on the back history of the autoclaves, and it'll give you an example of how this specific type of autoclave, the Finn autoclave, works. So please watch those videos. Again, video I had posted, it also go into the autoclave working and the principles behind it. So the working principle. So essentially, if you put something in autoclave, it's ultimately sterilization, and refers to the complete destruction of all forms of microbial life, including bacteria, spores, viruses, and fungi. So how does it work? It's the action of the steam ensures surface heating penetration and then denaturation of critical proteins and nucleic acids occur within the cell. So essentially, an autoclave wants it's a sterilization function, and it wants to destroy all forms of microbial life in order to make sure that it is as sterile as possible. So the denaturation results in the breakdown of intermolecular hydrogen bonds between proteins so that the structure and function of microbes is lost. It's used to sterilize the surface of tools or instruments, glassware, hollow tubes, petri dishes, and other types of production or lab equipment. And it's sterilized through physical means by using pressure, temperature, and steam. So that's the whole function of the autoclave and how it works and the purpose of it. So within the autoclave, you have cycles that it goes through. So we'll go through the sterilization cycle. So steam enters the chamber and conditions to load. Then you have air is displaced through the chamber drain. Steam process is low at selected time and temperature, and then steam is removed from the chamber and pressure is released. So it has three phases. So your heating phase, again, that's when steam enters the sterilizer jacket and air is removed from the chamber either by gravity, displacement, or pre-vacuum. So you heat, and then you go through your sterilization. Load is exposed to steam at a set temperature for a set time. And then after you heat, you sterilize, and you have your cool down phase. Sterilizer chamber is exhausted to atmospheric pressure, followed by circulating air through the chamber, drawing a vacuum. So this is the whole sterilization cycle and the phases that it goes through. So this is a high-level overview of the inner workings of the autoclave. Again, like we said, you have your steam that goes in, you heat, your steam, and then you want to release the pressure uh, through it as well. So this is just an ongoing cycle that goes on during the sterilization is running. So if you have any questions, definitely ping me, but this is gives you a high-level overview of the autoclave components. So if you wanted to go through an IQ, so again, if you're going through the validation stage, IQ, OQPQ, IQ is the first stage, installation qualification. You're asking yourself, is the unit installed correctly? So some of the action or questions you're asked, does the unit fit the space allotted? Is the unit installed at the correct height level? Is the piping, air, water, steam the appropriate size of materials? Are safety valves and check valves all present and operating smoothly? Compare to piping and instrumentation diagram, P&ID drawings. So you want to check all these things during your IQ, and ultimately you want to make sure these are done, and also compare what you have in your P&ID or your drawings and see what you actually have installed. Again, IQ going into the utilities. So you want to make sure the water, air, and steam pressures are all within acceptance criteria. You want to make sure the drain meets proper opening requirement. You want to make sure the electrical supply voltages all meet minimum requirements, and then the safety relief devices for chamber and jacket function. So again, from a utility perspective, this is some of the things you look for in the IQ. And then as startup test, you want to make sure there's everything startup or power up. If you do alarms function appropriately, are temperature and humidity able to be controlled? Is the chamber capable of withstanding its specified maximum pressure? You want to look at your documentation, all your vendor spec sheets, your manuals, etc. Make sure that's good to go. And then check door opening and safety obstruction switches. So again, things you want to look up at your startup test, dealing with your IQ.